Unit 2 discussion, continuous compounding. In this discussion, we'll learn about continuous compounding of interest. Continuous compounding means the number of compounding periods per year is basically infinite. You'll remember when we did daily compounding, we used n equal to 360. In continuous compounding, basically we're saying that the number of compounding periods per year is infinite. To calculate continuous compound interest, we use a slightly different formula, which is shown here. A is the amount that accumulates, P is the principal, R is the interest rate, again as a decimal, and T is the time in years. What's different in this formula is it uses the base E. E is called Euler's constant or Euler's number, and it plays an important role in many application problems. Your calculator may have a base E. It's usually a second function above the ln x key, or you can approximate E as 2.7183. So let's work a problem. Let's say we're going to invest $5,000 for 14 years at 3% interest. How much will accumulate if the interest is compounded continuously? So using our formula, A equals P e to the RT power, we put in the values $5,000 for the principal, the interest rate is 0.03, and our time is 14 years. And if I show the calculations here, I'm also going to bring up a calculator so I can show you how to do this on the calculator. So I have a scientific calculator here, excuse me, and I'm going to, now in this calculator, you have to put in the exponent first. So if we go over here and we look, our exponent is going to be 0.03 for the interest rate times the 14 years that we're investing for, and we get 0.42. Now that's the exponent that I want to raise the base E to. Now on this calculator, I don't see that E key. So I do see an ln key. So it's a second, I'm going to go second, and all of a sudden the e to the x key appears. When I press this key, it's going to go ahead and raise base E to that exponent. And I get the 1.5129, which I show down here. And then lastly, I'm going to multiply it by the principal. And so I come up with an amount of $7,609.81 rounded off to the nearest penny. For comparison, if we just invested compounded quarterly, we would accumulate $7,597.89. So the continuous compounding yielded more interest, $11.92 over the 14 years. So for this assignment, you're going to assume that you have $10,000 to invest, and you get to pick one of the 4 investment options shown here. Invest that $10,000 at 6% for 10 years, at 8% for 10 years, at 6% for 20 years, or at 8% for 20 years. So for the investment option that you selected, find the amount that accumulates if the interest is compounded annually, then find the amount that accumulates if the interest is compounded continuously. Considering the amounts that you calculate for questions 1 and 2, which one had a better outcome and by how much?